All right, so today we're diving deep into AI training and inference. AI's learn it and do it phases.
Right.
We'll uncover what goes on and where the real costs lie. Could be surprising.
Yeah, and it's easy to just focus on the potential of AI, but understanding how it actually works is key.
Yeah.
And that's where training and inference come in.
Okay, let's break it down. AI training, the learning phase.
Yeah.
Can you walk us through what actually happens?
Imagine teaching a dog a new trick, right?
Okay.
Show them what to do, you reward them, and repeat until they get it.
Right.
AI training is kind of similar. We feed it tons of data, and through trial and error, it adjusts itself to get better at a specific task.
And this data, we're not just talking about like a few spreadsheets, right?
Oh, absolutely not.
This is massive.
Mountains of information. Think self-driving cars, learning from millions of images to navigate,
Right.
or financial algorithms, years of stock market data to predict trends. It needs a lot of data.
Yeah. So that brings us to hardware.
Yeah.
Training these models must need some serious power, right?
Definitely. We're talking specialized processors, GPUs, TPUs,
Okay.
designed for those complex calculations in deep learning. And even then, training can take a long time.
Wow. Okay. So we've got this intense training phase, but then what? How does the AI actually use what it's learned?
That's where inference comes in.
Okay.
It's the doing phase. The trained AI uses its knowledge to make predictions or give output based on new data it's never seen.
So if training is like cramming for an exam,
Yep.
inference is like taking the actual test.
Exactly. Think about spam filters.
Okay.
They've been trained on a bunch of emails to recognize spam.
Yeah.
When you get a new email, the model analyzes it and decides if it's spam.
Right. It's happening all the time, isn't it?
Yeah.
Personalized recommendations, chatbots, even face unlock on our phones.
All inference.
It feels like magic, but there's so much going on behind the scenes.
Right. And it's happening constantly. Millions, billions of times every day.
Wow.
And that brings us to something interesting about the costs of AI.
Okay, I'm listening. What's the catch?
Training is a big investment up front, but the real cost, the one that keeps going, is inference.
Wait, so using AI is more expensive than building it?
Yeah, in many cases. It seems strange, but remember, inference is always happening at scale.
Right.
Each instance might be cheap,
Yeah.
but multiply that by millions, billions of times,
Price.
and the costs add up.
Like buying a car. The price tag's big, but then you have fuel, maintenance, insurance.
Yeah.
It all adds up.
Exactly. And with AI, those ongoing costs are mainly the resources needed to run inference, the energy used, and the infrastructure supporting it.
So we've got this, like, hidden cost with AI.
Yeah.
But why should we care? Why is efficient inference so important?
Well, first, just from a money standpoint, optimizing inference can really cut costs for businesses using AI a lot. It's about getting the most out of their investment.
Right, like streamlining any business process.
Right. But it's more than just money.
Okay.
The environmental impact of AI, especially inference, is a big concern. All that power needed to run AI models, it adds to the carbon footprint.
So it's not just about saving money, but about sustainability too.
Exactly.
Making AI inference more efficient could help reduce its environmental impact.
Absolutely. And that's why people are working hard to find solutions to make AI inference faster, cheaper, and greener.
Okay, so let's talk solutions. What are some of the strategies?
One of the most promising is specialized hardware.
Oh.
AI chips designed specifically to speed up the math behind deep learning.
So custom tools for the AI job.
Yeah. Companies like IBM and ARM are leading the way, building chips for everything from tiny sensors to huge data centers.
It's amazing how hardware and software are evolving together to push AI forward. But it's not just about faster chips, is it?
No, not at all.
There are other ways to make inference more efficient.
Right. Model compression is getting a lot of attention.
Okay.
It's about making AI models smaller and more efficient without losing accuracy.
Like packing a suitcase efficiently.
Exactly.
You want everything you need without the extra weight.
Exactly. Techniques like pruning, removing unnecessary parts, and quantization, using less data to represent information.
It sounds like a delicate balance.
It is.
Between the complexity of the model and the need for efficient inference.
Absolutely. And then you have middleware.
Middleware?
Yeah, it helps the AI model talk to the hardware efficiently, like a translator.
Okay, interesting.
Advancements in middleware, things like graph fusion and parallel tensors, They let the model break down complex tasks and do them at the same time.
So it's getting things done faster and using resources better?
Yeah.
Wow, it's like all these different parts working together.
It is, and what's really exciting is that there's so much collaboration.
Yeah.
Companies like IBM and open source communities like PyTorch, pushing the boundaries of AI inference and making it more accessible.
It's amazing how much progress is being made. It makes me wonder about the future of AI inference. What kind of breakthroughs are coming next?
Well, one area that's getting a lot of attention is dynamic batching.
Okay.
It lets the system group multiple user requests together so the hardware can work most efficiently.
So instead of one by one, it's like bundling tasks.
Exactly. And then there's quantization, which we talked about earlier, using less data to represent information.
Right.
This can really shrink the memory footprint of AI models, making them run faster.
It's amazing how much work goes into making these systems perform better.
It is.
And it's clear that this focus on efficiency is only going to get stronger.
Oh, definitely. As AI becomes more common in our lives, optimizing inference will be key. Not just for cost and performance,
Right.
but for making sure AI is sustainable and accessible to everyone.
This has been a great deep dive.
Yeah.
We've only just scratched the surface, but I feel like I've learned a lot already. What are your thoughts so far?
Yeah.
What parts of AI inference are you most interested in? Let us know in the comments.
As we go deeper into AI inference, it's clear that this push for efficiency is leading to some really amazing innovations.
Okay.
It's not just about tweaking the algorithms anymore.
Right.
It's about rethinking how AI systems are built from the hardware up.
We talked about those specialized AI chips earlier.
Yeah.
It feels like we're entering a whole new era of computing, where chips are designed just for AI.
Absolutely. These specialized chips, like the ones from ARM,
Yeah.
they're like finely tuned instruments
Okay.
made for the math of deep learning. They can do trillions of calculations every second.
Wow.
Perfect for the heavy lifting of AI inference.
And it's not just raw power, right?
No.
Energy efficiency is important too.
Exactly.
Yeah.
One of the best things about these chips
Yeah.
is that they can do those complex calculations using way less energy compared to regular processors. And that efficiency is really important as we move AI inference closer to the edge.
The edge. It seems like everything is getting smart these days.
Right.
Our phones, our homes, even cities are using AI.
Yeah.
What does this shift towards edge AI inference really mean?
It's a big change. Running AI models directly on devices instead of in the cloud,
Okay.
it has some real advantages. First, it cuts down on latency.
Latency.
Yeah, the delay. Imagine a self-driving car.
Right.
It needs to make decisions super fast. Processing data right there on the edge means much faster responses.
You don't want your car waiting for a signal from the cloud when it needs to brake.
Exactly. Edge AI inference is all about speed.
Okay.
And then there's privacy.
Right.
By processing sensitive data locally, we don't have to send as much personal information to the cloud.
So more secure and private AI systems.
Yeah.
It seems like edge AI inference can open up so many new applications.
It really can. Think about medical devices.
Okay.
Analyzing patient data in real time for personalized treatments.
Wow.
Or robots in factories that can adapt to changes instantly. Edge AI brings the power of AI to places we never thought possible.
It's like we're giving AI its own senses,
Yeah.
letting it experience the world directly. But this expanded capability comes with new challenges too, right?
Of course. Putting AI models on devices at the edge brings up issues of security and reliability. We need to make sure these edge AI systems are tough, tamper-proof, and able to work even in difficult conditions.
So it's not just about speed and efficiency anymore.
Right.
It's about making AI resilient and trustworthy.
Yeah.
Especially as we rely on it more.
Exactly. And that's where things like model compression become even more important.
Okay.
By making AI models smaller and less complex,
Yeah.
we can make them easier to use on devices with limited resources
Right.
and less likely to make mistakes.
It's amazing how all these pieces fit together. Specialized hardware, edge computing, and model optimization. All driving the evolution of AI inference.
It's all connected.
And as AI keeps evolving, we're going to see even more innovation, blurring the lines between the digital and physical worlds even more.
Absolutely.
I'm excited to see what the future holds. But before we get too carried away, let's talk about some practical challenges.
Okay.
One that comes to mind is the sheer amount of data we're creating.
Oh, yeah. The data deluge is real.
It's overwhelming.
It's a big challenge for AI inference. It's not just about storing and processing all that data.
Right.
It's about making sure the data is good quality.
We don't want to be feeding AI models with garbage.
Exactly. Garbage in, garbage out.
Right. Training an AI model on bad data will lead to bad results.
Absolutely.
We need to be really careful about that.
Yeah, data pre-processing and cleaning are so important.
Okay.
It's about finding and fixing errors, making sure the data is consistent, and ensuring that the data used for inference is accurate, relevant, and representative.
So a lot of work goes into preparing the data before it even gets to the AI model.
Yeah. It's not just about giving the model as much data as possible. It's about giving it the right data.
Data is like fuel for AI.
It is.
But it needs to be refined.
Exactly. And that's where data scientists come in. They understand the data and can use the right techniques to make sure it's good quality.
So it's a team effort.
Yeah.
Not just computer scientists and engineers, but data scientists and experts in the field where the AI is being used.
Absolutely. AI needs people from different areas to be successful.
And speaking of collaboration, I'm really impressed by the role of open source communities in AI innovation.
Yeah, me too.
Platforms like PyTorch. It's like a global brain trust.
It is.
Where developers and researchers from all over share their knowledge and build tools that make AI more accessible.
Open source communities are so important for AI to move forward.
Yeah.
They're creating a culture of collaboration, transparency, and fast innovation. By making tools and frameworks free, they're making AI available to everyone and empowering a whole new generation of developers to build amazing things.
It's really inspiring to see this level of collaboration and sharing.
It is.
It shows the power of open source.
For sure.
And as AI keeps changing, I think open source communities will play an even bigger role in shaping its future.
Absolutely.
This has been a really interesting look at the challenges and opportunities in AI inference. We've covered so much.
Yeah.
From specialized hardware to data quality and the importance of open source. Before we wrap up, I want to hear from you. What are some of the AI applications that you're most excited about? Or maybe a little worried about? Share your thoughts in the comments below. And if you're enjoying this deep dive, make sure to like this episode and subscribe to our channel for more explorations into the future of technology. It's amazing to think how far AI has come. Self-driving cars, personalized medicine, it's changing everything.
Yeah.
And like we said, this push for efficient inference is a big part of that.
It really is. Being able to run AI models quickly, cheaply, and sustainably, it opens up so many possibilities. But we also need to think about the downsides, the challenges of this technology that's changing so fast.
Yeah, it's like we're in uncharted territory. We have to be careful, make sure AI is used responsibly and for good. One thing that worries me is the environmental impact of all this computing.
Right.
We talked about how training a big AI model can be bad for the environment.
And it's not just training. The energy used by AI inference happening all the time on a huge scale, that's a problem too. As we use more and more AI, making it more energy efficient is really important.
So it's not just about speed and cost, but about being environmentally friendly too. Are there any solutions in sight?
There's some interesting stuff happening with neuromorphic computing.
Okay.
It's a whole new way of thinking about computing, inspired by the human brain.
Neuromorphic computing, that sounds cool.
Yeah, it's about creating chips that are both powerful and energy efficient.
So we're trying to build artificial brains.
Yes.
Chips that work like our neurons.
Exactly. Instead of using zeros and ones like regular computers, neuromorphic chips process information more like our brains do, using spikes of electrical activity.
So it's not just copying the brain's structure, but how it processes information too. What are the advantages of that?
Well, one big one is that neuromorphic chips are parallel processors. They can do many things at once, like our brains.
Right.
That makes them really good for things AI is good at, like recognizing patterns and making complex decisions.
And that means they save energy too, right?
Exactly. Because they only use energy when they need to, unlike traditional chips that are always using power.
So they're much more efficient.
Yeah, which could really reduce the environmental impact of AI.
It's fascinating that the solution to making AI more sustainable might be in the human brain. But while we're talking about copying human intelligence, we should also talk about AI copying our biases.
That's a really important point. AI learns from the data it's given. And if that data has biases, the AI will have those biases too.
Right, like those facial recognition systems that have trouble identifying people of color or hiring algorithms that are biased against women.
Exactly. AI isn't neutral. It reflects the data it learns from and the people who create it.
So how do we fix that? How do we make sure AI is fair and ethical?
It starts with recognizing that bias exists in all data. We have to find ways to identify and reduce it. That means having diverse teams working on AI, people with different viewpoints who can challenge each other.
It's about thinking about the social and ethical impacts of AI.
Yes.
Not just the technical stuff.
Exactly. And it's not just the developer's responsibility. We all need to be part of this. By talking about it, asking tough questions, and demanding transparency, we can help make sure AI is used for good.
This has been a really thought-provoking deep dive into AI inference. We've covered so much, the technical details, the need for efficiency, and the ethical challenges. I'd love to hear your thoughts. What stood out to you? What questions do you still have? Share your comments below, and let's keep talking about it. And if you enjoyed this episode, make sure to like and subscribe for more explorations of the future right here on The Deep Dive.